We are going to talk about the apple sawfly model. Let's select a weather station and open the apple sawfly model. We are now past the critical season for apple sawfly. So we'll zoom out to see what happened earlier during the year. Apple sawfly, Hoplocampa testudinia, is an hymenoptera that overwinters in the soil of the orchard. The apple sawfly model is split in different graphs. The bottom graph is modeling what happens in the soil during the season. At the beginning of the year, the insects are in diapause in the soil, in black on the graph. Around mid-March, Northern Hemisphere, diapause ends and the insects start to pupate. During pupation, in grey on the graph, development rate is proportional to soil temperatures. When a certain sum of heat units is reached, the insect emerges as an adult and start flying in the orchard. Emerging adults are modeled in light blue. Only a few weather stations are equipped with soil sensor temperatures. As a consequence, soil temperature is assimilated to air temperature in the calculations. For this reason, depending on the nature of the soil, there might be some little differences between the first insects that you trap and the first insects modeled in RIMpro. If you observe the first insect before the model, you can set the date of the first capture. You can change this date in the menu, Administration, Biological Parameters, or clicking on the clock icon next to your station's name. Now let's zoom in on the middle graph to see what happens once that the adults have emerged. Female adults are modeled in dark blue. They only fly during daytime. Flight activity is proportional to air temperature as long as it is over a lower threshold. If there is rain, no flight is simulated during the hours of rain. Most of the time adults emerge on sunny days, during the apple blossom time. The pink area that you can see in the background is modeling the fresh flowers that are blooming. After mating, female adults, in dark blue, are laying eggs under the sepals of the fresh flowers. It's very important to set your blooming dates carefully because this will determine the susceptible period in the model. Fresh eggs are modeled in white. And then embryonal development is split into 6 stages according to different morphological criteria. The last egg stage, called the red eye stage, is the most critical because it means that the eggs will hatch within a short time. It is also the best moment to spray your insecticides because most of them are efficient on young larvae. The model is indicating with a vertical bar the recommended application date based on hatching. The young larvae, light brown, burrow into the receptacle often just beneath the skin. The tunneling by the larva creates a large russet scar forming a circle. When larvae are semi-mature, in dark brown, they often move to another fruitlet, often within the same group of flowers, boring into the ovary and feeding on the pips. When larvae are fully fed, they leave the fruit and enter the soil to form a cocoon and overwinter. If you have questions regarding this model, do not hesitate to send us a message at support@rimpro.eu.